Hi friends, welcome to lesson number 3. Now we are looking at applied force at an angle. In the previous lesson, we looked at applied force that was horizontal. Okay, let's read the statement. A force of 30 Newton is applied to a box at an angle of 45 degrees to the horizontal, causing it to move to the right at a constant velocity along a rough surface. Great. So there's a couple of things that we must look at. First thing first is that the force is angled. Let's go on and mark that. We have an angle of 45 degrees, and it has a magnitude of 30 Newton. Lovely. What else do we have? They say the surface is rough, so that means we have a frictional force. Since we are told that this block is moving to the right, frictional force opposes motion like we discussed in the previous lesson. So frictional force will be going to the left if the object is going to the right. So we have kinetic friction going that way. What else do we have? We said as long as something is on a surface, there must be normal force. And we say that normal force is going to be perpendicular to the horizontal, to the plane itself. So I'll just put it there. And then we said also, as long as something exists, as long as it occupies space, as long as there's mass, it will have gravitational force, Fg. Okay. As long as something has mass, it's going to have Fg. So that's the force that you can never get wrong because it's always there. So those are the forces that are acting on the object. I just like to first label my forces. It makes it easy, okay, before I even start reading questions. Right. So the first question is, okay, and another thing to look at is that they said constant velocity. And we discussed in the previous lesson that if we have constant velocity, it means F net is going to be 0. Also, because the acceleration is 0. Lovely. I was just doing a recap and also labeling some stuff. Determine, is the object accelerating? No. There's constant velocity. Remember I said you must memorize this. When there's constant velocity, there is no acceleration. Lovely. So no, the object is not accelerating. If they ask you why, because the velocity is constant. Lovely. Number 2, determine the magnitude and the direction of the kinetic frictional force. All right? Previously, the force was parallel. It was collinear with the frictional force. So we just added them directly. There was no problem there. This time, we have an applied force that is at an angle. We can't just allow the 30 Newton to interact with the frictional force. We need to break that 30 to its horizontal and vertical component. Why? The frictional force that we're looking at is acting horizontally, is horizontal. So in order for it to interact with any other force, that other force must also be horizontal. So we will go and break the 30 Newton into its horizontal component. That's the one we are looking for. But we must also break it into its vertical component. The two components meet at 90 degrees. I will call this one Fx. I'll call the vertical Fy. I'm taking it from mathematics that the vertical axis is the y-axis and the horizontal axis the x-axis, all right? So Fx is my horizontal component of that 30 Newton force. Fy is my vertical component of that 30 Newton force. Remember, both Fx and Fy come together to form 30 Newton. They are the components. They come together to form the same thing if you use Pythagoras. Now, let's not forget what we're looking for. We are looking for the frictional force. So we are breaking that force into components so that we can have something to work with along the horizontal. You can only add two forces that are parallel directly. Now I'm building from what? Lesson 1, the vectors, okay? If you missed that, please go first, watch the vectors in lesson 1, then come back here. Okay, let's choose our direction. I did advise you that take the direction of motion as your positive. This thing is moving to the right. I will take right as the positive direction. And if that's the case, it means the Fx is going to be positive since it's going to the right. And the frictional force is going to be negative since it's going to the left, opposing our positive direction. So we're going to have minus Fk. Remember, when we sum forces along a particular direction or along the horizontal, they must be equal to ma. When we sum them, they must be equal to ma, because F net must be equal to ma. But since we have a constant velocity, F net is 0. So we're going to equate that to 0. Great. Fx, we need the value of Fx in order to work Fk. How can we work out Fx? We can take advantage of trigonometric ratios. We have our Fx is a side that is adjacent to the 45. And we also have the hypotenuse there, the 30. So what is the trigonometric ratio that combines adjacent and hypotenuse? Well done. If you said it's cos, it's going to be cos. So cos of 45 is going to be Fx over 30. That is adjacent over hypotenuse. To make it easy for you, when things are like this, just say is 30 cos 45. Once you identify your trigonometric ratio, just say it is the 30, which is the applied force, cos of the angle. That's going to be your Fx. This is your Fx. Minus the Fk. It's going to be 0. Okay, let's go ahead and punch this into the calculator. 30 cos 45 is going to be 21.21, rounded off to 2 decimal places, minus Fk equals to 0. I'm going to transpose the Fk so that it can be positive there. So 21.21 equals to Fk. Okay, I know most learners, they want the subject to be on the left. I'll go ahead and flip that. 21.21 Newton. Our frictional force is going to the left. So there's the magnitude, there's the direction. We've answered that question. Okay? I hope you understood everything that we're doing there. We're going to move on to the next question. Lovely. Question 3. Determine the magnitude and direction of the normal force. First thing first, identify your force. Check where your force is going. Here's our normal force. It's going up. It's a vertical force. So we are only interested in vertical forces. This time we're going to ignore our kinetic friction. Why? It's horizontal. We're going to ignore the horizontal component of this force, like Fx, we're going to ignore, but we're going to focus on the vertical component, which is Fy. So, since normal force is vertical, we're interested in the normal force. Fg is vertical and Fy. Those are the 3 forces that we want to work with because they are collinear or they are parallel to each other. Okay, let's go ahead and make an equation using the vertical forces. We first choose the direction. Upwards is positive. Great. Meaning anything that goes down is going to be negative. Let's go and make some beautiful equations. We're going to take the normal force as positive since it's going up. We're going to take the Fy as positive since it's going up as well. But we're going to take the Fg as negative since it's going down. Equals to what? Constant velocity. Okay, but now, along the vertical, there is no movement. This thing is not rising up and it's not sinking down. So there is no movement there. The acceleration is 0. We're going to have equals to 0. The F net is going to be 0. Now let's go ahead and fill in what we can fill in. Let's first work out the Fy. like we did previously, let's check. We have the angle of 45 degrees. We have the 30 Newton there because we are told that the applied force is 30 Newton in magnitude. So what do we have? Fy itself relative to the angle is it's opposing the angle. The 30 is hypotenuse. Now, what trigonometric ratio combines opposite and hypotenuse? Beautiful, well done. It is sine. So because you're going to use sine, we are going to say 30 sine of the angle. That will give us Fy. Okay, and then we have Fg that we need to find out, that we need to work out. Fg is mass multiplied by gravity, which is equals to, the mass is 5 and the gravitational acceleration is 9.8. So let's go ahead and plug this back there. Normal force is what we are looking for, plus 30 sine 45, then minus 5 multiplied by 9.8. That is the Fg equals to 0. Look, you can first clean it up and get what the value is there, and get what the value is there, and just plug those values there. Okay? Yeah, don't be like me, don't be lazy. But even if you do it this way, it's still okay. And when we punch that into the calculator, what do we get? We get minus 27.79 if I did it well. Just confirm. And then we're now going to transpose this, take the other side, so that we can be left with n. So n is going to be, when we transpose that, it's going to be 27.79 newtons. Where is the normal force going? It's going upwards. Upwards. So we have the magnitude and we have the direction. We've answered U as well. Okay, let's recap. When you have a system, okay, and there are forces acting there, identify and label your forces. It makes life easy. And also, when you're reading the statement, check your keywords, stuff like rough surfaces where the frictional, it tells you there's frictional force. If they said smooth surface, it will mean no frictional force. Now we have, look at keywords like constant velocity, that tells you the F net is 0, acceleration is 0. And then, is your force, applied force angled or is it horizontal? If it's angled, break it into its components. Okay? If it's horizontal, that's fine. Perfect. And then, when they ask you questions, if they want a frictional force, first identify where your frictional force is. If it is horizontal, only deal with horizontal forces. Make equations using only the horizontal forces. Then, like here, we were looking for normal force. Identify your normal force. It is vertical. Only work with the vertical forces when you're looking for that normal force. And be careful of your directions. Choose the positive direction first. And everything opposing that direction going to be negative. And then take the direction of motion as positive. And anything opposing that is going to be negative. I hope you understood. I will see you in lesson 4, where we're going to be drawing free body diagrams. I can send you off.